This video is about finding the greatest common factor, and the goal is I can find the greatest common factor of a polynomial. First, let's start with the review exercises. The directions state find the simplified form of each expression. So for number 1, I need to distribute that monomial to that binomial. So first what I'm going to do is I'm going to multiply the numbers on the outside. So negative 4 times 8 is a negative 32. Then I'm going to combine my x terms by adding the exponents. So remember we have an invisible 1 right here, so that's x cubed. And then for the y's we have y to the 5th power, so I added the exponents. Now I'm going to do a negative 4 times a negative 7, which is a positive 28. Then I'm going to add the exponents for my x terms. So x times x is x squared. And then I still have the y cubed. And that is my final answer. For number 2, either you can use distribute twice, or you can use the box method. I'm going to distribute, so I'm going to multiply the 3a times the 3a and the 3a times the positive 5. So I'm going to do that first. 3a times 3a is 9a squared, so I'm adding the exponents. And then 3a times 5 is a positive 15a. Now I'm going to do negative 5 times 3a and negative 5 times 5. So negative 5 times 3a is a negative 15a. And a negative 5 times a positive 5 is a negative 25. Now I'm going to combine like terms. Positive 15a and a negative 15a equals 0. So now I'm left with 9a squared minus 25. Now let's talk about the greatest common factor. And what the greatest common factor is the largest factor that all terms have in common. Now let's try some example problems. The directions state find the greatest common factor of each polynomial. So first what I'm going to do is I'm going to look at all the numbers in front of the variables. So I have 5, 25, and 45. What I'm going to do to any of the numbers that I can break down further, I'm going to write all their factors and I'm going to use a little tree diagram. So 5, that doesn't break down into anything, so that's just going to stay as 5. But 25 breaks down into 5 times 5. And then 45 breaks down into 5 times 9. We can continue to break down 9 further into 3 times 3. Now what I'm going to do is I'm going to use all of the terms at the bottom of the trees. So for the first term, 5x cubed, all we have is that 5. So I'm going to write 5 times, now x cubed means x times x times x. So I'm going to write that out. Then we have plus, now I'm going to write our second term. So the 25 broke down into 5 times 5. So I'm going to write 5 times 5. And then we have x squared. So times x times x. And then our last term is plus 45x. And the factors of that, if we look at the bottom of the tree, we have 3 times 3 times 5, and then times the x. So now we have to look at each individual term, and we have to see what's in common between each of the terms. This is what I'm noticing right now. I have a 5 here, a 5 here, and a 5 here. All of those are in common between the 3 terms that we have. So therefore, part of our greatest common factor is a 5. Let's see what else we have. it looks like we also have an x in common in each of the terms. So I'm also going to include an x. Now we can't say that there's a second x in common because that third term doesn't have a second x. So our greatest common factor for this polynomial is 5x. Let's try number 2 now. We're going to do the same thing. So 3x to the fourth, the 3 can't be broken down any further, so that's going to stay. The 9 can be broken down into 3 times 3, and the 12 can be broken down into 3 times 4, and the 4 is broken down into 2 times 2. Now I'm going to write out all of these terms. So the first one, I have 3x to the fourth, so I have 3x times x times x times x times x, so 4 x's, minus, I'm going to use the terms at the bottom of the tree, so 3 times 3, and then I have 2 x's times x, and then I have minus 2 times 2 times 3 times an x. Now I'm going to look and see what's in common in each of those factors. So I notice that I have a 3 in common in each of the factors. So for my greatest common factor, we're going to start off with a 3. And then I notice that I have 1x in common between all the factors. And that's it. We don't have another x or another 3 or another 2, so our greatest common factor for this polynomial is 3x. Let's try number 3 now. So I'm going to do the same thing. I'm going to break down the 12 into 4 times 3 and 2 times 2. And for the 24, I'm going to break it down into 6 times 4, 3 times 2, and then 2 times 2. It wouldn't have mattered if for 24 you decided to pick 8 times 3. You still would have received the same factors at the very end. Okay, so now let's write out all of our factors. So we have 2 times 2 times 3, and then we have times x, and then we have y to the fourth, so that means 4 y's. 1, 2, 3, 4. And then we have our plus sign. And here's our second factor. So remember, only write the numbers at the bottom of the tree. Don't write the 6 or the 4. So we have 3 2's, 1, 2, 3. And then we have a 3. And then we have x squared, so 2 x's and 3 y's. Now let's look and see what's in common. It looks like we're going to have a lot in common for this one. So it appears that we have one group of 2's, so I'm going to write 2. We have another group of 2's, so I'm going to write times another 2. We have a group of 3's in common, so I'm going to write times 3. We have an x in common in both, so times x. We have a y. We have another y. We have 2 y's. And we also have a third y in common. So if I simplify this, our greatest common factor would be 2 times 2 times 3, which is 12. We have 1x and we have 3y, so y cubed. So our greatest common factor for this polynomial is 12xy cubed. Let's try our last problem, number 4. We're We're going to do the same thing. So 9 into 3 times 3. 27 breaks up into 9 times 3 and 3 times 3. And 12 breaks up into 4 times 3 and then 2 times 2. So here we have a lot of terms to write. So we have 3 times 3. We have 4 A's, 1, 2, 3, 4. And we have 5 B's. I'm going to write these underneath. 1, 2, 3, 4, 5, just so we can save some room. Plus, I'm going to write the second term in a different color. We have 3 3's, 1, 2, 3. We have 1 A. We have 2 B's. And we have 4 C's. 1, 2, 3, and 4. So that's our second term. And then our third term, we have minus, and then we have 2 times 2 times 3, and then we have 3 B's. So now I'm going to look and see what's in common in each of these, and it looks like they all have a 3. So I have 1 3 in common. So for our greatest common factor, we have 1 3. And it looks like we don't have any A's in common. So let's look at our B's. So I have 1 B, 1 B, and 1 B. So I have 1 B. Let's see if we have 2 B's in common. So I have another B, and another B, and another B. So times B. So if I simplify that, my greatest common factor is going to be 3b squared. Now hopefully you guys will be able to get a little bit quicker at this process and not have to write out all these terms in order to find the greatest common factor.